Great. Well, thank you all for joining. I'm delighted to be here. I first want to start by acknowledging, with respect, the Lekwungen peoples on whose traditional territories I am zooming from today, and the Songhees and Esquimalt and Wasatch peoples whose historic relationship with the land continues to this day. I'm going to talk about a high-level ocean-based carbon dioxide removal, and then a specific project that Ocean Networks Canada is leading. I just want to warn you that there's two terms that are interchangeable: negative emission technologies and carbon removal. Both of them are really almost talking about the same thing. I just want to touch on Ocean Networks Canada. For those of you who don't know us, we are based on the fact that the ocean is a complex system of everything from physical oceanography to biology to interaction with the coastline to interaction with the atmosphere, and also in British Columbia, which are one of the most dynamic geologic seafloors in the world, with a subduction zone, earthquakes, hot venting, and the location of Canada's first marine protected area that is a site for hot vents. So Ocean Networks Canada observes all aspects of the ocean and monitors them. And we have a lot of infrastructure. Our biggest infrastructure is the Neptune Observatory, an almost 900-kilometer long telecommunication cable. And we now host thousands of sensors that deliver data 24/7 to observe those aspects I just told you about. This is our physical infrastructure. There's many other extension cables that are not shown on this map. We also have systems on ferries, and now we've expanded along the rest of along the coast of Canada in other ways. We have a digital infrastructure to support all this data. Our principle is no stranded data allowed. We monitor and remote and troubleshoot that whole network of sensor systems. And we have interactive control systems that allow scientists to do experiments interactively or automatically or through some kind of trigger. And of course, all our data are following Canada's open data policy. So I welcome you all to use our data openly and freely. And so because of that data system, we have systems now along the coast of BC in the Arctic, and now we have some even on the East Coast, and partnerships with First Nations, their Indigenous peoples in Labrador and the Maritimes. And the reason I'm showing you all of this is because some of the work we're already doing in the climate space is developing data for climate change adaptation, sea level rise, ocean acidification in those areas. But what we're moving to is also adding to our portfolio climate change mitigation. That means reducing carbon dioxide in the atmosphere. And I'll explain why that's really important. So why is there a need for negative emissions or carbon dioxide removal? This is a stylized graph from the UN Environment Program, really showing you that we obviously have to rapidly remove our reduce our emissions very quickly. There's some countries are meeting their targets, others have not yet, and some of us are not yet on track. But what you see is from the dark blue to the light blue is that we are going to need to have removal of carbon dioxide in order to stay within a temperature of the planet to keep human life habitable. And this is a stylized diagram. We likely need carbon removal as quickly as possible, but certainly it's going to be essential by 2050 because we will still have some emissions that are happening. We're going to have to offset that, even if we do the best job possible in reducing emissions. So it's not about any question about the need. It's needed, and so it's important to invest now so that those removal technologies are available, especially when they're needed. And there's a lot of people working on this at the moment. So in 2019, the U.S. National Research Council, which publishes the work of the U.S. National Academies, published a report on negative emissions. And these first four lines are really the estimates of broad areas of how many gigatons per year could this kind of work, these kind of activities reduce carbon in the atmosphere. What they didn't talk about in that report was details about other ocean-based carbon removal systems. They also touched on the bottom line idea was combining direct air capture with subsea floor or geologic ocean-based carbon mineralization. So I'm just going to first touch on this first one, and that leads into what we're talking about here today. And then later on, I'll talk about the final one on that study. So now there's a new U.S. National Academy committee that's doing a study on ocean-based carbon removal, and I'm on that committee. I'm really happy to be on that committee. That work is going on. We just had a workshop this week, and these are the areas that we're looking at of carbon removal that are as ocean-based. So what you can see here is that all of them are probably needed in some form or other, but we have to assess whether or not they would be causing environmental damage or unexpected negative impacts. So this report will come out with research recommendations and recommendations for some or all of these carbon removal options. I just want to point out what you're going to hear from Mike in his talk is really the last one on this list which was the ocean alkalinity enhancement, and it's exciting to see there's some commercial effort going into that already, even without all this pre-research going on. So let me touch on this air capture and seafloor carbon mineralization piece. This is what Ocean Networks Canada is now leading a team of people working on it. And it came from work that a company called Climeworks did in Iceland quite a number of years ago now. I think it's almost 7 or 8 years. Climeworks is a technology company that does removal of CO2 from the atmosphere by basically filtering it using a chemistry. They're pulling that CO2 from the atmosphere, and they're using the heat, geothermal heat from Iceland, which is a benefit. And they pumped it into the ocean, the basalt that's above the ocean, because it's one of the only young basaltic rocks that's sitting above the ocean in the world. And they demonstrated that this rock, the CO2, reacted with the basalt, ocean crust, and became rock in 2 years, a very short amount of time. So this is what's called a durable sequestration option, pumping gaseous CO2 or dissolved CO2 in water into basalt, and it mineralizes with rock. It was published quite a long time ago in 2016, demonstrating this in the top journals, and just last year, another publication demonstrating its efficacy as a durable sequestration solution. So what we're doing is following not only what's happening in Iceland, but also trying to advance the transformations for a sustainable ocean economy that Marie Chantal mentioned. This report came out about a month ago, and in this report, one of the actions is to advance carbon capture and storage in the subsea bed through international collaboration, et cetera, et cetera. So we were really happy to see that what we're proposing in Ocean Networks Canada and the work we're doing in this area is part of this transformation document. So we have a project that's funded. It's called Solid Carbon. It's a feasibility study, and it has basically 3 elements. We're combining air capture in partnership with carbon engineering, which is similar to CarbonWorks, although a different kind of CO2 air capture system called direct air capture of CO2. Putting together a feasibility to how to put that on an ocean platform, powered by renewables, in a location where you can pump it through the through the water column into the subsea floor and into ocean basalt. Now you say, well, why don't we just do it on Iceland? 95% of the basalt in the world is in the ocean. Hence, we view this as one of those solutions that could become a global scale technology, bigger in size, likely to the offshore oil and gas production industry, to be able to then be online to do that negative emissions or carbon removal, to be one of the solutions, not the only, but one of the solutions, but an important one. And so this is just a conceptual diagram on the left of what that possibly could look like. There's other combinations like pipelines and subsea floor injection, et cetera, that we're looking at all of those options right now. And we're funded by the Pacific Institute for Climate Solutions. We're in our 2nd year of the feasibility study. We were also selected by the MacArthur Foundation 100 and Change competition as one of the top 100 projects in the world for addressing the big issues on the planet. We have many partners that are growing all the time. Now, why are we as a part of it, Ocean Networks Canada? We're a part of it because we have real-time sensor systems at a place called Cascadia Basin, which is the best characterized ocean basalt location on the planet. And we also have boreholes there, and we also have real-time monitoring. So we've been working with Columbia University now for over 6 years to really look at this as an option for doing a demonstration here first, demonstration that it is as durable as the Iceland example. And if we can demonstrate that, like in Iceland, now Climeworks and that Icelandic effort has big investments going on because the demonstration was successful and industry is moving forward with investing and commercializing that work. We want to do the same thing here, make it Canadian led and make it Canadian know-how that can be exported. To give you an idea of scale, this is the Cascadia Basin. It spans the US and Canada. It has a capacity to store about 20 years of global CO2 in that location alone. And this is just a very approximate of the other locations and comparing them to the locations of offshore oil production. But there's many locations on the planet in the right kind of water depths, in the right kind of age of ocean basalt that could also be these reservoirs for capture. We have an international team of partners in this effort. And so I just want to close by saying we're really excited about being part of feasibility for one example of carbon removal that's ocean-based, but it really will need a big effort to get all of these going. And I think you're going to hear more from the next speaker about how they're moving forward in a commercial way. But we need coordinated effort from both public and private interests. That's very clear. We might want to think about mimicking, these are 2 US programs, DARPA, which is Defense Advanced Research Program, and the National Institute of Health, where they're investing to accelerate, and what the National Research Council is here in Canada is trying to do, to accelerate in industry's ability to market themselves in this what will be a big industry. And of course, one of the examples that the US always talks about in terms of how they really kick off innovation and how the US has been one of the most successful innovator in the world is that they use government procurement to kickstart innovation. And we need to also explain to our own government that that is a wonderful tool to kickstart these innovations and for Canada to lead. So that's my presentation. We're proud of being Ocean Networks Canada, delivering ocean intelligence for climate solutions, adaptation, and now climate change mitigation through a feasibility study on carbon removal. So I'll stop there, and thanks for listening to my presentation. I think I turn it over to Michael, is that right?
Yeah, so yeah, I just, if there's any questions for Kate right off, if you could just let us know, put it in the chats. We can entertain a question or two before we get Mike to speak. She's said a lot, and I just wanted to highlight this government procurement piece. We are trying as a federal government. We have our challenges that are out there, the BCIP program. So we are trying to do that, but that doesn't mean that we don't have room for improvement. So I think as we go forward, we need to realize that we are doing our best, but we need feedback to make sure that we have that right. I don't see any questions. Wait for a second. Okay, so if you do, please put it in the chat. We'll make sure to answer them. And then Mike, the floor is yours.